God's number is the maximum number of moves it takes from any given solvable position on the Rubik's Cube to solve it. There are two possibilities for a move: a half turn and a quarter turn. This is a half turn, and this is a quarter turn. Though a seemingly simple problem, it took a strong team of mathematicians and computer scientists, along with access to Google's supercomputers, to solve God's number in the half turn metric. We interviewed a member of the team that figured it all out. Meet Tomas Rokicki. Mr. Rokicki is a computer scientist that led the team that found God's number in the half-turn metric. He was extremely kind and allowed us to interview him so we could find out in greater detail about how exactly he and his team reached God's number. Mr. Rokicki started off by telling us that the main limitation to their experiment was not a lack of methodology, it was actually just computing power. There are 43 quintillion possible solvable orientations on the Rubik's Cube, and computers just did not have enough memory at the time to deal with that. So the alternative would be to solve each of those positions using some sort of algorithm that would solve the cube in an extremely efficient way. Here's where the two-phase algorithm comes in. A mathematician by the name Herbert Kosiamba wrote this algorithm. He worked closely with Mr. Rokicki on the project. The algorithm basically worked by first figuring out a way to get the cube into a specific subset of positions, and secondly solving the cube from that position, and that's a lot easier once you get there. The two-phase algorithm, in about a millisecond, solves most positions on the cube in about 20 moves. However, since each position only takes a millisecond, even then, a millisecond times 43 quintillion is still a really long time, so this method was not viable either. Then the way they solved this next was with symmetry. The same solution can be applied to different positions on the cube if you just hold it differently, because of how symmetry works. So the amount of positions that were not symmetrical and unique in that regard was about 1 quintillion. The next thing Mr. Rokicki and his team did was write a program. This took about 10 years to write. This program solved a billion different positions on the cube at once. It originally took hours to run, but eventually they were able to make it so efficient that on any modern machine it could be run in only a second. 1 quintillion divided by a billion is just a billion. So the team needed to run this program a billion different times so that they could solve 1 quintillion positions on the cube, and because of symmetry, that would in turn find solutions for every position on the cube. That's where Google came in. Their computers were so powerful that this could all be done simultaneously. Apparently, Mr. Rokicki was not allowed to see the supercomputers. Instead, he gave his code to his friend who worked at Google, and he ran the code. To summarize, the team implemented the two-phase algorithm to solve a billion positions of the cube at a given time, and ran that a billion times, and compiled all the data in order to see what the greatest number was, and that number was God's number, or 20 in half-turn metric. You can see a history of attempts to solve for God's number and a summary of his team's research on the website cube20.org. Another fun fact: Mr. Rokicki was actually hoping that there'd be one position which was actually solved with a maximum of 21 moves. So he actually reserved the domain cube21.org as well before he released his team's research, but didn't end up using it. Thank you for watching.